Hello everyone. So today we're gonna learn how to solve linear inequalities. So before we get into an example, so let's first talk about some rules that you need to know before solving those linear inequalities. Meaning some rules that you need to follow if you want to solve those linear inequalities. So rule number one. So adding or subtracting a number doesn't change the sign of inequality. So adding or subtracting a number doesn't change the sign of the inequality. So first let's just write an example here. So let's say 2x minus 1 greater than 4. So when I say the sign of the inequality, I'm talking about this sign here, greater or less, greater or equal, or less or equal. So that's what we're talking about here. So, and rule number two, it said multiplying or dividing by a negative number reverses the sign of the inequality. And look here, I said a negative number only, but if you're multiplying or dividing by a positive number, the equality sign doesn't you can don't reverse we do not reverse the inequality sign. Only we reverse the inequality sign only when multiplying or dividing by a negative number. And what I mean by reverse the inequality sign means if it is greater then we make it less than. That's when we multiply or we divide by a negative number. And the same goes for less than. If it is less than, we reverse it to greater than. So let's do an example, and that's rule number two. So let's do an example here. So let's let's solve this example. So let's change the color here. Let's check another color. So let's say we want to solve this example. So we have 2x minus 1 greater than 4. Again, so before we do that, let's first see how do we solve this if it was a linear equation. So let's say we have 2x minus 1 equals 4. Because all the steps that we do for solving linear equations, we do the same steps when we solve linear inequalities. So what we do when we want to solve the linear equation, what we usually do, for example, if we have this example here, 2x minus 1 equals 4. Again, the goal here is to isolate x on the left side and everything else on everything else on the right side. So what we do is, if we have a negative 1, we first get rid of this negative 1. If we want to do that, we add 1, because the inverse operation of subtraction is addition. So we add 1 on the left side, and since this is an equation, what we do to the left side, we do it to the right side. So we have to add 1 to the right side as well, and then we get 2x equals, this will cancel out, equals 4 plus 1, which is 5. And then the next step would be we have x multiplied by 2. So what we do is if we want to get rid of this 2, we divide by 2, because again the inverse operation of multiplication is division. And what we do to the left side, we do it to the right side. So we also divide the right side by 2, and then 2 will cancel out, and we get x equals 5 over 2. So this is the solution for this linear equation. And if we want to solve this linear inequalities, we do the same here. So we add 1 to both sides, okay, and then we get 2x. And again, since we're adding a number, we do not reverse the sign of the inequality. So we get 2x greater than 5, okay. And the next step would be is getting rid of this 2 on the left side, and we have x multiplied by these 2. So what we do is we divide by 2 on the left side, and we do the same thing here. But notice here, this is very tricky. Notice we're dividing by a positive number, not a negative number. Here it said we reverse, so we cannot reverse the inequality sign. It said only when we divide or multiply by a negative number. Here we're dividing by a positive number. That means we do not change the sign of inequality. So we get 2 will cancel out. We get x greater than 5/2. Now going back to comparing the solution of linear equation and the linear inequalities to better understand the solution of linear inequalities. So let's do that. So here, notice that the solution to this linear equation on the left side is only 5/2. That means x equals 5/2. Means 5/2 is the solution to this. So if we take 5/2, we substitute x. We substitute 5/2 for x here. This will hold. This equation will hold, meaning that this 5/2 solves this linear equation. But here, on linear inequalities, so if we have, so if this is our number line, okay, so 0, and this is our number line, so 5/2 would be somewhere here, 5/2, okay, and solutions to this linear inequalities is all the numbers that are greater, because it said x is greater than 5/2. It means all the numbers that are greater than 5/2 means all the number, like 5/2. What would be the next number? 5/2 is literally 2.5, right? So 2.6, 2.7, 2.8, I will go all the way up to plus infinity. Okay, so if we take, let's see, 4 would be a solution to this linear inequality. Why? Because 4 is greater than 5/2. If we take 10 is a solution to this linear inequality. Why? Because 10 is greater than 5/2. So all the numbers that are greater than 5/2 solves this linear inequalities. So let's say if we have greater or equal. So let's see, we have x. Great, change the color here. Let's change the color 1 second. So let's say we have x greater or equal than 5/2, meaning that 5/2, if we just have greater, not equal, not or equal, if we just have greater, meaning that 5/2 is not a solution to this linear equation or linear inequality. But when we say greater or equal, that means 5/2 also solve this linear inequalities. So let's first let's go back to our first solution. So we had x greater than 5/2, so meaning that 5/2 does not belong to our solution set. So let's do another representation of our solution set. So let's say we use the interval notation this time. X greater than 5/2, meaning that 5/2 up to plus infinity. It means all the numbers that are greater than 5/2 solve this linear inequalities. And this is how we represent it in notation, in the interval notation. And over here we just do an open closed parenthesis on 5/2, meaning that 5/2 does not belong. And also in the interval notation, 5/2 does not belong to our solution set. But if we had greater or equal, then what we do here on this number line, we do a closed bracket going towards plus infinity. And in the interval notation, this is how we represent it: a closed bracket, 5/2 up to plus infinity. So this is for x greater than 5/2, and this is for x greater or equal than 5/2. So this is if we want to represent it in the interval notation. Okay, here x greater or equal than 5/2, meaning that 5/2 also solves this linear inequality. So let's do another example so you will better understand this. Okay, so let's say we do another example here. Let's change the color. Let's go back to blue. Okay, so let's say we have minus 5x minus 1 less than 4. Okay, again, what we're gonna do here is we have to add let's because this example is very close to the other example that we did. So let's change it. So let's say minus 5x plus 3 less than minus 2. Okay, so the first step is, again, to want to get rid of this 3, we subtract 3, because the inverse operation of addition is subtraction. And what we do to the left side, we do it to the right side. So we also subtract 3, negative 3 here. And then we get minus 5x. This will cancel out, less than minus 5, right? And what's our next step? So we divide by, if we want to get rid of this negative 5, because there is x is multiplied by negative 5. So what we do, if we want to get rid of it, we divide by negative 5. And since, again, going back to our rules, since this is, we're dividing, also, by the way, we have to also divide the right side by negative 5. And since we're dividing by a negative number, we go back to rule number 2, where it said multiplying or dividing by a negative number reverses the sign of the inequality. So we have to reverse the sign of the inequality. So we get x. Now we're gonna have x greater, because we have to reverse the sign, and negative 5 over negative 5 is just 1, meaning that our solution set. So let's represent that in number line. So if this is 0, this is 1, and we have x greater than 1, it means that again, x is greater. It doesn't say x greater or equal, it's just x greater than 1. It means all the numbers that are greater than 1 up to infinity, up to plus infinity. So, and we do an closed parenthesis. Okay, all right. So, and if we want to do that in an interval notation, we do it, we do an open parenthesis, 1 up to plus infinity, and this is our solution. It means any number that we take here, let's say we take what is some number that are greater than 1? Let's say 100. So this 100 is greater than 1. Whatever number we take is a solution to this set. Okay, it's a solution to this linear inequality. So let's do another example. So let's say, choose a different color here. Let's say we have 1 over 5, negative 1 over 5x plus 2 greater or equal than 3. So the first step would be subtract 2, because we want to get rid of 2 here. We did the same, we subtract 2 on the left side, so we did the same thing here on the right side. We subtract 2, and then we get negative 1/5 x. And notice that we're adding, we just subtracted a number. It doesn't have to be negative, or it could be negative or positive, and again, that does not change the sign of the inequality. So we get greater or equal than 1. And now we have to negative 1 over 5 times x. If we want to get of this rid of negative 1 over 5, so either we divide by negative 1 over 5, or is the same thing as multiplying by the inverse of negative 1 over 5, which is negative 5, which is negative 5 over 1. So this will cancel out, negative 5 will cancel out, and 1 will cancel out. Okay, so, and since we are, notice that we multiplying here. Okay, and what we do to the left side, by the way, we have to do the same thing here. So we multiply by negative 5 over 1, or just negative 5, but let's just write negative 5 over 1 so you don't get confused. Okay, so, and since we are multiplying, notice that we're multiplying by a negative number. There is a negative sign here, means that we have to reverse this sign of the inequality. So we get x less than or equal. If it was greater than or equal, we put, if we reverse it, we do less than or equal. So we have to keep that or equal, okay, for reverse the sign. So we get negative 5. We get x is less or equal than negative 5. So if we go back to our number line, so that if this is a 0, negative 5 is somewhere here, of course is going to be less than 0, and it said that any number, when we say x is less than or equal to negative 5, it means that any number here less than or equal to negative 5 is a solution to this linear inequalities. And since we have less or equal than negative 5, meaning that negative 5 is also included. Okay, it means that negative 5 is also included in our solution set. Okay, up to minus infinity, up to minus. So let's just write this over here. 5 less or x less or equal than negative 5. It means that all the numbers that are less than or equal to negative 5 up to minus infinity is a solution to this linear inequalities. And if we want to write that in interval notation, we'll write it from negative infinity up to negative 5, but this time negative 5 is included, so it's gonna be